Hello friends, welcome to my channel. In this video of development of surface, we will develop the lateral surface of this right circular cone. You can see this is the right circular cone. So if we'll unfold this cone, let's say this is the cone. So we have to see its developed surface. So if I'll unfold this cone, this will be the shape of the developed surface. So this is a sector of a circle. So here this dimension and this one, these both are equal and is equal to slant height of the cone. You can see this is equal to slant height of the cone, and this dimension, this arc, is equal to the length 2 pi r. This arc is equal to 2 pi r, that is circumference of the cone. You can see 2 pi r. So let's develop its lateral surface on the sheet. So very first we have to draw the top view of the cone, then front view of the cone, and then we'll develop it. So you can check the statement in the description box. The dia of the cone is 60 and height is 80. So here I'm taking the radius as 30 mm. Now this is the top view of the cone. Let's draw its front view. Here we have to take the height 80. You can see from this reference line we have taken the height of 80 as per the given data. Dia 60 and height 80, and this line is at center. Now let's take the projection from this edge. This is the first projection, this is the second projection. Now this is the front view of the cone. I hope this part is clear to you. This is the front view of the cone. So now this is top, this is front, and this line is equal to slant height. So let's copy the slant height at the distance of 15 to 20 mm. I'm taking the gap of 15 mm here. You can start developing it from this edge also, but it's better to take the distance and start developing from some distance. I hope this part is clear now. So now we have to draw this surface. Now we have to draw this surface, this sector of circle. So slant height is there. Now we'll draw an arc. This is the center of the arc. Now we have to draw the arc equal to 2 pi r slant length. Now the question is, this is slant height, this is 2 pi r circumference. So the question is how to measure the length of the arc. With the help of compass we can draw the arc. So we have prepared this arc, but the question is how we will confirm the length is 2 pi r, that is circumference of the cone. That's not possible. So here we will find out the corresponding angle of sector, angle of the sector corresponding to this arc. So what would be the angle here? This line is equal to slant height, this line is equal to slant height, and this arc is equal to 2 pi r. So this angle theta is equals to arc upon radius. Arc is 2 pi r and the radius of the sector is slant height. So this will give you the result in radians. So you have to convert it in degrees. 180 by pi, so pi will get cancelled here, and finally the theta will be equals to 360 into radius of cone upon slant height. So you can put the values here. The 360 into radius of cone is 30 and slant height is approximate 85.5 or 85.6. In my drawing I am getting 85. You can apply Pythagoras also, or simply you can measure it with this scale also. So here the angle will be around 127 degree. You can calculate this. Angle of the sector is 127 degree. You can take a screenshot of this. So now let's measure this angle. This is 0 degree, this is 90, 100, 110, 120, 125, 126 and 127 degree. This is 127 degree, right? So here you can see there was some mismanagement in the space. We have to, it was supposed to start the drawing little bit downside, but no problem, we'll continue with this. Now this is the developed surface of the cone. This is the developed surface of the cone. Now further it is given that the cone is truncated by the cutting plane, which is passing through the midpoint of the axis. This part is very important. The next part is part 2, adding the cutting plane, and we have to develop the lateral surface of truncated part, this frustum of cone. You got my point? In the statement it is given that the cone is truncated by a cutting plane. Cutting plane means this portion has been removed and this portion is left. So we have to develop the lateral surface of this frustum of cone. So as per statement it is given that the cutting plane is passing through the midpoint of the axis at the angle of 45 degree. So let's take the midpoint first. So from here we have to measure the angle of 45 degree. Angle. The cutting plane is passing through the midpoint of the axis at the angle of 45 degree. Now this is the cutting plane. So it means to say this portion has been removed and this portion is left, and we have to develop the lateral surface of this frustum of cone. So what's the procedure here? In case of generator, basically there is no edge, so we have to draw the imaginary edges. We have to draw a few imaginary lines on the surface of cone. These lines are called as generators, because when we'll truncate this cone, when we cut this cone, here the height will be different, here slant height will be different, here slant height will be different. So we'll draw the imaginary lines. These imaginary lines are called as generators. So minimum 8 number of generators are required to develop the surface. So when we'll develop this, then you will understand why 8 number of generators. Zero, 20, 30, 40, 45. Take 45 degree angle this side. Similarly from here also take 45 degree angle, because we have to divide this in 8 equal parts. One more thing is there, the generators should be thin. It should be a thin line, continuous thin line. Now these are the 8 number of generators, 1, 2, 3 and so on. Now take the projection of these all the generators in front view. This is the projection of 2, 8. This is the projection of 3, 7, which is coinciding with the center line. This is the projection of 4, 6. This is apex O. This is O dash. So now let's join these all the generators to the apex. Let's join these all the generators to the apex. Now you can see I'm joining these all the generators to this apex. So now this is projection of generator first, 1 dash, this one is 2 dash, 8 dash, 3 dash, 7 dash, 4 dash, 6 dash, and this one is 5 dash. So now it's very simple to understand that this portion has been removed and this portion is left, and these are the different heights on the surface of cone. Different heights are there for different generators. So now we have to distribute these all the heights in this surface. So similarly, after unfolding this cone, same 8 number of generators will be here. So see how to divide this. So the angle was 120, theta was 127 degree. So we'll divide it by 8. So this angle will be approximate. It will be 15.8 degree. So here manually it is very difficult to measure that angle. So we'll take the angle approximately. This is 10, 15. So just near to 16 degree we can take this angle. One more thing you have to note down this. At the end you will get some error. Right, in manual drawing it will happen. At the end you will get some error, because error will be multiplied. If here you are taking the error of like minor error, 1 degree, 0.1 degree is there, so it will be multiplied with 8. So don't worry for that, we will rectify that. So this is the first angle of the first subsector. So now we can say if the sector is divided in 8 equal parts, all these subsectors will be same, all the sub angles will be equal, all the arcs will be equal, and all the chords will be equal. So let's copy this chord. Second, this one is third, this is 4, this is 5, 6, this is 7, and last one is 8. We will see it here. Just give me 1 minute. Let's fix it here. Let's extend this arc. So you can see here some error is there. So here you can erase this line, previous slant line, this slant height or radius of this subsector. So now we'll follow this, right? So this was the error. So this error will happen in the manual drawing. There is no such problem, but in dimensions we have to write the actual dimensions, right? Slant height, this is 2 pi r. Because whatever the result we are getting, that is in decimal places, and least count of the scale is 1 millimeter, and least count of the protractor is also 1 degree. So you can see I am using the continuous thin line here. Now we have to do the labeling. This is 1, 2, 3 and so on. Right? We have divided the sector in 8 equal subsectors. Last point, if you are lacking with space, then increase the R. And if some extra space is there, then erase that. But divisions should be perfectly equal. You have to show divisions should be equal. No problem. In manual drawing some error will be there. Don't worry. Now we are left with 2 steps. We have to distribute all the heights in this sector. So 2 steps are there. Step 1. Collect all the points on 2 slant height. This is the height of generator 1, 2. You can note down 1, 2. Sorry, this is only 1. This is the height of generator 1. We have transferred here. Now next is 2, 8. It is getting truncated here. You can mark the point here. So here this one was 2, 8. The next one is 3, 7. We have to collect all the apparent slant heights on true slant height. This is slant height, but this is now equal to half of the height. These all are the apparent slant heights. Now this is 4, 6. and last one is 5. Sometimes what we are doing is we are just measuring it like this. This is 2.8. We are measuring it here and we are transferring here. That is incorrect. Don't use this directly because this is apparent slant height. First we have to collect it on true slant height for correction. If this value is x, this value will be more than x little bit. So this was the second last step. Now the last step. Take your compass here. Open it equal to 0.5. This is 5. So now which one is 5? This one. So distribute the point here. This one is 0.5. This is the first point. Now next is 4.6. So rotate your compass. This is 4 and this is 6. So you can mark the point here. This is 4 and this is 6. Next one is 3.7. This is 3. This is 7. Next is 2.8. This is 2 and this is 8. The next one is 1. So this is already generator 1 and last one is also generator 1. So these are all the points. Now we have to connect all the points with the curve. You have to draw freehand curve here. Now this is the developed surface of frustum of cone, this portion. This line you can convert it into a thin line because this portion was removed. We can convert this line into a thick line. We can keep this line as it is. So this is the developed surface of a right circular cone, which is first, and second part is the development of frustum of cone. After adding this cutting plane, the remaining portion is frustum of cone. So this is the developed surface of frustum of cone. So in case you have any doubt or any question, you can post your comments and subscribe to the channel, please. Thank you so much.